Hello and welcome to a brief introduction to the JTeC dataset. So, first of all, just to give you a bit of an idea of what actually JTeC is. JTeC is a large collection of Java test cases for test code analysis and processing. And it encompasses more than 2.6 million Java test cases spanning over more than 31,000 GitHub repositories for a total of 431 million source lines of code. And to the best of our knowledge, this is actually the biggest data set explicitly focusing on testing artifacts, which is available at the moment. And our final goal is the one to provide researchers with the means to conduct experiments on the large-scale test suite and large-scale testing artifacts, which are becoming more and more common in industrial contexts. JTeC is a dataset which is ready to be consumed, which means it doesn't require any independent repository mining or pre-processing of data. It can be just downloaded. It is publicly available. The link to the dataset is available in the description of this video. And the requirement to use the dataset is pretty bare bones. So the dataset itself weighs less than 2 gigabytes. And the only thing which is really required is a way to extract a tar.gz file, which is actually the format, the compressed format in which the dataset is provided. And optionally, in order to take full advantage of the capabilities provided by the JTeC bundles, you would need Python 3 or above. So let's continue with a brief overview of what the JTeC bundle actually looks like. So this is the content of the bundle once you extracted the tar.gz file available online. And in the JTeC folder resides all the test source codes which constitute the dataset. And it follows the standard hierarchical structure tree of GitHub repositories. So basically username followed by project name. And then throughout the mining process, we preserve the original location of the test files for each repository. And in addition, there is the JTeC CSV file, which provides a swift overview of all the projects included in the dataset. And here we can find information such as number of test files included in each repository, the size of the test suites in terms of bytes, lines of code of the test suites, and so on and so forth. And in addition, we provide also the capability to further filter and trim the dataset according to specific criteria. And to build JTeC, we conducted a very preliminary quality filtering carried out by removing all test suites which contained less than 5 test cases. But this might not be enough for researchers. So we also provide a quality filtering script with which the datasets can be further tuned. And this is implemented in this Python script quality filters, and the parameters are specified in the config.json file. And let's have a brief look here. Most of the parameters are self-explanatory, such as minimum and maximum number of test files which each repository should contain, or if we should consider forks or not, and so on and so forth. And one thing I want to bring your attention on is the clone parameter. And this variable provides the capability to execute dry run in order to have a swift overview of the quality filtering output without actually creating the new dataset. And just to give you a brief example, let's say I want to study some characteristics of big test suites. I will hence put the minimum number of test cases, and let's say here I want 5,000. So I will save this file, I will leave the clone variable to false, and I will execute the quality filter script. And this will generate a new file called the JTeC clean file, in which I have an overview of all the projects included in this filtering step. If then I want to generate the real dataset and I'm satisfied with the current tuning of the parameters, I will simply set this variable to true. I will execute it again, and this will generate a new folder called JTeC clean, which corresponds to the new dataset just created via the quality filter. Thank you for your attention and happy experimentation.